Good evening, viewer. Welcome to our Glory Globe TV. Here's the breaking news. Yes, researchers from Rockefeller University and the Ikahan School of Medicine at Mount Sinai have made a discovery regarding the effects of addictive drugs like cocaine and morphine on our brains. They analyzed the brain's reward pathway and tried to answer why these substances can take over our natural desires for essential needs such as food and water. Lead researchers Jeffrey Fredman said, "We have known for decades that natural rewards like food and drugs can activate the same brain region. But what we have just learned is that they impact neural activity in distinctly different ways." One of the big takeaways here is that addictive drugs have pathologic effects on these neural pathways that's distinct from, say, the physiologic response to eating a meal when you are hungry or drinking a glass of water when you are thirsty, he added. Using mouse models, the research team employed a comprehensive approach to study the impact of cocaine and morphine on the brain's reward circuits. By mapping brain activity, imaging neurons, and analyzing genetic activity, they tried to understand how these drugs influence neural pathways. The study reveals the crucial role of the nucleus accumbens, that is called NACs, in both typical brain functions and drug rewards. Neurons projecting to the NAS from the orbitofrontal cortex are implicated in reducing natural reward responses when activated by drug use. The NAC is a key node where the underlying dopaminergic neurons direct and refine animals' behaviors towards their goals. Neuroscientist Bowen Tan told Science Alert, "What we weren't able to understand is how repeated exposures to drugs corrupts these neurons, resulting in escalating drug-seeking behaviors and a shift away from healthy goals," he added. While cocaine and morphine activate specific subsets of neurons in the NACs, their effects differ. Cocaine, a potent stimulant, and morphine, an opioid, elicit unique responses in the brain, ultimately altering behavior and preference for these drugs over basic needs. By tracking these cells, we show that not only are similar cells activated across reward classes, but also that cocaine and morphine elicit initially stronger responses than food or water, and this actually magnifies with increasing exposure. Neuroscientist Caleb Brownies wrote, "After withdrawal from the drugs, these same cells exhibit disorganized responses to natural rewards in a manner that may resemble some of the negative affective states seen in withdrawal in substance use disorder," he added. Repeated exposure to cocaine and morphine leads to a shift in behavior, with mice exhibiting increased interest in drugs and decreased interest in food and water. This change is accompanied by alternation in neuron communications, affecting how the brain processes rewards from natural stimuli. The study identifies a protein encoded by the REP gene that interferes with typical neuron communications, contributing to addiction-related behaviors. Understanding these pathways opens avenues for developing targeted therapies to combat addiction. Behind this exclusive report, Glory Globe TV, Delhi, Bharat.